Hello and welcome back to e-CBSE online classes. We are continuing the module probability for mathematics class 10th. Specifically, we are looking at exercise problems and this is part B3 of the video series. Let's take the first exercise problem. The problem statement reads like this. A missing helicopter is reported to have crashed somewhere in the rectangular region shown in the adjacent figure. What is the probability that it crashed inside the lake shown in the figure? Okay, you understand the problem? Right side there is a picture given and some dimensions are also given. When a helicopter has crashed somewhere in the rectangular region, they are asking what is the probability that the crash has happened inside the lake. What is the event here? The crash happening in the lake, correct? And it is equally likely to happen anywhere in the rectangle. And what is our definition of theoretical probability? It is the ratio of number of outcomes favorable to E divided by number of all possible outcomes. Okay, here there is no number given. Those are dimensions given for a rectangular area and we need to calculate the probability from the dimensions. So we need to assume that the number of outcomes possible will be proportional to the area. Here the favorable outcome is inside the lake and all possible outcomes are within the entire rectangle, correct? So if I assume that my number of outcomes will be proportional to the area of the region available, the formula can be rewritten as probability of E is equal to area of lake divided by area of rectangular region. Okay. Now let's go ahead and calculate each of these values. Let's work on the rectangular region area first. We are given the dimensions as 9 kilometers is the length and 4.5 kilometers is the breadth. So the area of rectangle is equal to 9 into 4.5, that is 40.5 square kilometers. Now we need to work on the area of the lake, right? The dimensions are not directly given here, but we can calculate because there are some partial dimensions given in the other part of the picture. So we know that 9 kilometers is the total length of the rectangle. If I remove 6 kilometers from that would be the length of my lake. Okay, that is 9 minus 6 is equal to 3. Now let's work on the breadth of the lake. So here the major dimension is 4.5 and out of that we remove 2 kilometers. So my breadth of the lake will be 4.5 minus 2, that is 2.5 kilometers. Okay, so the area of lake is equal to 3 times 2.5, that is 7.5 square kilometers. So this is going to be my numerator. So probability of E is equal to 7.5 divided by 40.5. So if I multiply both numerator and denominator with 10, that becomes 75 by 405. After simplification, it becomes 5 by 27. So the probability that the helicopter has crashed inside the lake is 5 by 27. Okay. So this is a slightly different problem where the number of outcomes are not directly given. So we are assuming that number of outcomes are proportional to the area of the regions given in the picture. Okay. Please note that. Now let's work on another problem here. Exercise problem number 4. When you toss a coin 3 times, what is the probability that there are, the first part of the problem is 2 heads and the second is at least 1 tail. Okay. Now the probability definition is number of outcomes favorable to E divided by number of all possible outcomes, correct? Now let's see first what are all different possible outcomes. When you toss it for the first time, it can be either head or tail, correct? And now when you do the second toss, for each of these first possibilities there will be again 2 possibilities. It can give head or tail, can give head or tail. Again, for all these 4 combinations, during the third toss there will be 2 possibilities each. That will be 4 times of 2, 8. So it becomes either HRT, 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 HRT. So here I am representing head by H and I am representing tail by T. Okay, so there are 8 total different branches. If you write down the combinations here, the first combination is H, 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 which is all heads. Second combination is head, head and tail. And similarly, you write down all the combinations here. So total there are 8 possible outcomes. That will be my denominator for both the sub problems given in the problem discussion. Now, what is the assumption here? All these outcomes are equally likely, correct? Because this is a fair coin. There is no bias towards any particular outcome. Now, let's work on the calculations for the first subset. The event here is total 2 heads. We have already identified all 8 possible combinations. Out of these, let's identify what are the outcomes which have 2 heads in the result. 1, 2, and 3. These 3 outcomes have 2 heads in the result. So, number of outcomes favorable to the event that we have defined is 3. So, this is going to be my numerator. So, the probability of 2 heads when you toss a coin 3 times is equal to 3 by 8. Okay. Now, let's work on the second subset problem. Here the event is at least one tail. Okay. So, either you can get that thing by looking at the all possible outcomes and identify all the outcomes which have at least one tail, or you can work around slightly differently, which is an easier path, which I am going to show now. When my event E is at least one tail, my complementary event E bar is no tail at all. That means all heads. Here I have only one outcome which is all heads. Okay. So number of outcomes favorable to E bar is just 1. So P of E bar is equal to 1 by 8 because my denominator is 8 as we have calculated earlier. So P of E is equal to 1 minus P of E bar, that is 1 minus 1 by 8, which becomes 7 by 8. So the probability of at least one tail is 7 by 8. Okay. This is again simple way to solve these problems. All you need to do is just understand the problem correct, define your assumption, and list out all your possibilities, and from that identify what are your favorable outcomes for the event that you have defined, and take the ratio of it to get the correct probability. Okay. Before we close the video, let us quickly look at the food for thought scenarios that we have given in the very first introduction video for the probability module. The first one is you are offered a lucky draw coupon for $100. Prize money is $1 million. Total number of coupons being sold are 100,000. Will you buy the coupon ticket and why? Second scenario given is there are 50 students in your class. Without even looking at the actual date of birth, your teacher makes a bet with you that at least 2 students will have same birthday. Will you take that bet and why? As we have discussed, the probability concepts that we have discussed in these modules will help you to decide in such situations. Try to work out these problems and post your answers in the comment section. If not, we are going to work these examples or solution for these problems in the next video, which will be our last video of this module. Okay, I hope you like this video. Please like, share, comment, and subscribe to our channel e-CBSE online classes, and follow us on Facebook. Thank you for watching.